So in the previous 11.5 release, we introduced the new module, SmatrixMeasuredOpt, so you can see it here. And this module reads user-defined scattering matrices. They could be obtained from the measurements. They could be obtained from the some device-level simulations. But one of the features is particularly interesting is that it supports so-called parametric S-matrices. So imagine your S-matrix depends on some parameter. So in our case, this is the grating length, but it could be any parameter, for example, temperature, or maybe some material properties. And you have defined this S-matrix for several of the parameters, but now you want to simulate for something in between. And so we previously supported one algorithm, which is based on correlation. And however, although it worked well for many cases, in some particular and pretty peculiar cases, it didn't really give very good results. So as you can see, so these two transfer functions correspond to our measured data, which is provided in the file, while this one, the blue one, was generated automatically. So in order to overcome this issue, we introduced the new algorithm, which is morphing-based algorithm. So now if you want to specify it, you go inside the file and you can introduce this keyword, parameter interpolation, and you can set it to morphing. So let me open the S-matrix file and to show you how it is done. So I have it currently commented, and so by default we use the correlation algorithm. So now if I uncomment this and save and run the simulation again, we can see that the generated interpolated transfer function is much better and it's much closer to the actual transfer function. So you see this morphing algorithm in some cases could really improve your results. So even more, we still have full flexibility. We can use morphing algorithm, correlation, or just very simple linear algorithm is also supported. So you can actually combine and use different algorithms for magnitude and phase. So you see we enclose them in those braces and specify separated by space. So this one will correspond to the magnitude, this one to phase. We can use different algorithm for different transfer functions, and this is the syntax how this could be introduced. So yeah, please explore the documentation. So if you go to help file for the SmatrixMeasuredOpt module, there are more details. So now we introduce one more improvement. Particularly since we generate this S-matrix, we need some integrity controls. So we introduced the passivity and causality checks, which could be introduced by these new parameters, check passivity and check causality. So it just checks, if you run the simulation again, we can see that, okay, actually the S-matrix we generated for some transfer function, causality could be, check could fail. And this doesn't mean right away that there is something wrong with your S-matrix, but it is definitely worth looking into your transfer function, maybe checking other characteristics of the transfer function.